GATE 2018 Civil Engineering Set 2 Question 26. The matrix 2 minus 4, 4 minus 2 has 4 options are given. A. Real eigenvalues and eigenvectors. B. Real eigenvalues but complex eigenvectors. C. Complex eigenvalues but real eigenvectors. And D. Complex eigenvalues and complex eigenvectors. The relevant NPTEL reference has been cited. Coming to the useful data, if we need to find the eigenvalues of a matrix, what should be done is, if the matrix given is A, we subtract lambda times the identity matrix of same order as A. So if A is n cross n, we subtract an identity matrix of the same order. We take this determinant of the matrix and equate it to 0. What this gives us is the characteristic equation in terms of lambda. By solving this, we get the different lambda values for the matrix, which are called the eigenvalues. Secondly, we need to find the eigenvectors. To do this, we do A minus lambda I, where lambda should be taken respectively into the corresponding eigenvector. This should be equal to 0. Similarly, if we have another eigenvalue lambda 2, we subtract it from A, multiply it with the new eigenvector x2 and make it 0. So x1 and x2 in this case represent the eigenvectors for the matrix. In this case, the matrix that has been given is 2, 4 and minus 2. To find the eigenvalues, we subtract lambda I from this and make the determinant as 0. So taking 2 minus 4, 4 minus 2 minus lambda times of identity matrix, that would be 1, 0, 0 and 1, we would get 2 minus lambda minus 4, 4 minus 2 minus lambda. The determinant of this should be made as 0. This would give minus of 2 minus lambda into 2 plus lambda plus 16 equals 0. Solving this would give us lambda square plus 12 equals 0. This would give lambda square as minus 12, which can be written as 12 I square. This would ensure that the eigenvalues are plus minus 2 root 3 I. So we can see that the eigenvalues in this case are complex conjugates. Now we need to find the corresponding eigenvectors for these eigenvalues. So let us call the first eigenvalue as lambda 1, which is 2 root 3 I, and the second eigenvalue as lambda 2, which is minus 2 root 3 I. So A minus lambda 1 into I into x1 will be 0. Doing this, 2 minus 4, 4 minus 2 minus lambda 1 I, that would be 2 root 3 I, 2 root 3 I, 0, 0. This whole matrix into x1, that would be 2 elements, because the matrix here A is of n cross n order. Eigenvector would be of a order n cross 1, would be 0. Solving this would give 2 minus 2 root 3 I minus 4, 4 minus 2 minus 2 root 3 I into x1 x2 equals the null matrix that can be written as 0, 0. Taking the expansion along the first row of A will give us 2 minus 2 root 3 I into x1 equals 4x2. This would ensure x1 by x2 as 4 divided by 2 minus 2 root 3 I. Following the same process for the second eigenvalue, that is minus 2 root 3 I, we would get 2 plus 2 root 3 I minus 4, 4 minus 2 plus 2 root 3 I into x1 x2 equals null matrix 0, 0. Expanding along the first row, we would get 2 plus 2 root 3i into x1 equals 4x2. This would give x1 by x2 as 4 divided by 2 plus 2 root 3i. So we can see that both the eigenvectors 1 and 2 are complex as well, along with the eigenvalues that are complex conjugates. So the matrix 2 minus 4, 4 minus 2 has complex eigenvalues and complex eigenvectors, which is option D. The relevant NPTEL reference has been cited.